It's all working. Yeah, we checked it. Yeah.
Okay, good. Well, good afternoon again. Welcome back. Thank you for being so prompt. As I mentioned in my introduction, this next session is going to be live streamed to the 17th Dutch-Belgian Information Retrieval Workshop, DIR 2018, held in the University of Leiden in the Netherlands. One of the disadvantages of live streaming is that they don't like us to start later than 3:45, but they definitely don't like us to start earlier than 3:45. So I will count us down, which is not quite yet. Yes.
On whose watch?
My watch.
Right.
Which is radio controlled.
could have turned this into a group exercise, yes, to count down together, but...
Right, my radio-controlled watch says it is now 3:45, so we can begin. And it's my great pleasure to introduce the 2017 winner of the Strix Award to deliver the 2018 Tony Kent Strix Annual Memorial Lecture, Professor Maarten de Rijke, who is Professor of Computer Science and Information Retrieval at the University of Amsterdam, and he's going to talk to us about retrieval as interaction. Maarten.
Thank you. Thank you, Doug. Right, so thanks for giving me this opportunity, for giving me this honor, and also thank you all for showing up here. It's great to see you, also in Leiden. Right, so what I'd like to do is share with you some ideas around this notion of retrieval as interaction. So you'll see lots and lots of examples, some short, some a bit longer. I think it's nice to have the sort of historical talk before the break, and now we'll hopefully have a talk that looks a bit more forward. It's recent, ongoing work with lots of people. So before I start, I should thank all of them for engaging in this work with me. I'm not going to read out all of them. Some of you are here. Thank you. Some of you are not. We're still good friends. Some are actually in Leiden. And we're still good friends, yes. So let me start by giving you a bit of background, and then from that we'll take two big notions, and those two big notions, safety and explicability, I'll illustrate with a couple of examples from our recent and ongoing work. Right, so this is not Leiden. So we had a definition discussion just before the break, so let me add on top of this, so this is what I take to be a useful working definition, getting the right information to the right people in the right way. Now there are, we know, and that was also touched on before the break, there are hundreds of, perhaps even thousands of conditions, features, characteristics that play a role in determining what is right, for whom, when, and how. And so this is not something we do by hand. This is something that a machine should learn for us, how to do this. And it's also not something we can actually do in a traditional supervised manner. It's just impossible to do all the labeling required for this. So machines should learn this. And we have our first new tweet in from Leiden. Machines should do this by interacting with the world around them, and then hopefully getting information that's more right to more of the right people in more of the right way. So there are two phases to thinking about information retrieval systems in this way. Two phases, offline development and online development. Once you've done your offline development work, you put it online, you make it interact with people, and you make it learn from these interactions to improve its behavior. And so then after a while, this will be the picture. Now, those two phases, they're important. One way of thinking about these two phases is that the system is an agent. The agent takes actions, tries to discover the success or failure of its action based on signals it receives from the environment. What's the environment? Users and their behavior in response to an answer, a ranked list, a recommendation. Some of these signals might be explicit, but most of them are implicit, so it's not actually trivial to find out for the system to determine whether it did right or wrong. And so it goes through these phases over and over and over again, and we might occasionally take it out of the online phase, do more offline development, and then take it back online. And so this is interesting to think about retrieval as interaction in this manner, because this is a learning process both for the machine and for the human searcher, right? The machine has to sense, has to reason about what it observes, has to make a plan about what to do next, and then execute its preferred action. What does the sensing mean? Understand what the user wants as well as it can, track the intent of users through these interactions, update the models, update the space of possible actions, answers, ranked lists, result pages, next utterance in a conversation, and then select the best one, and again sense the effect. So to some degree, in this world, life is easier for systems because it's an ongoing process. There's always a next action. There's always a next move in this game. And so as long as the system is able to keep engaged with the user, it's good. It can actually, in that process, educate the user, train the user, that it wants certain information out of the user in a certain way. It could ask for clarifications. But it's also harder in different ways, because it is now interacting with people directly. It's trying to improve its behavior by interpreting what people do, say, don't say. And it might be harmful in many ways. So it has to avoid this. Should not hurt anyone. We'll talk for a bit about what that means in a few seconds. But it also means that it should reveal enough about its own mechanisms, its own decisions, its own mistakes to users, so that users can continue to engage with it. So that's what the rest of the talk is about, safety and explicability, these two notions. I'll give you a bunch of examples to show you where I think we have some first answers, but also where a lot more is needed in terms of questions to ask and answers to those questions to be found. So we'll start with safety. Here we are again, not in Leiden. So safety is what? There are different readings of this. So one certainly is when you take the system that was trained offline, you take it online and let it then try and improve itself from there on. It should not drop in terms of performance below what you developed offline already. It should not disappoint people. People have certain expectations, and it should at least meet those expectations, but preferably outperform them. The learning, when you learn, you take risks. So the learning should ideally not take too long. Improvement should happen faster rather than slower. It should be able to learn not just from a select group of people, but from whatever users come along, and give all of them a fair deal. And it should, in particular, not fall into various sinkholes. Get trapped, lose diversity, create lots of tunnel vision, what have you. So I'm going to take you through a few examples of recent and ongoing work that try to address different safety aspects. And so each of these examples will sort of look like this. We'll have some plots, we'll have a what is the problem bullet, and then some steps towards solutions. And so here's the first example. This is work that will be presented in a few months at Wisdom in Melbourne. So one way to be safe for a system is to not learn online, but to learn offline from logged behavior. Now, there's something interesting there, right? The logging is done with one system. It takes certain actions. You're trying to develop a new system. It will take different actions. It should, because it's new. And the more these new actions are different from the actions that the old system would have taken, the more uncertain you'll be in inferring how good or bad the actions are. However, the advantage is you don't need to do online interventions and take online risks. And so because of that, an area of counterfactual evaluation, counterfactual learning has come up, has also reached information retrieval. A term you'll see there is off-policy evaluation. So you're evaluating using data collected by a different system. Now, a challenge there is that the reward signal, the signal that tells you whether you're doing a good job or not, might change because underlying user behavior might change. Users' preferences may change. This may be gradual, this may be sudden. If you don't correct for this, you'll go hopelessly wrong after a while. How can you correct for this? Well, together with Rolf, who's also here, one of the students in our team in Amsterdam, looked at different ways of forgetting about old experiences and focusing more on recent experiences that hopefully better reflect the changed user behavior. The changes can be sudden, disruptive, shown in the middle, or they can be more sudden, more gradual. Gradual changes you'll see, for instance, in music recommendation, where consumers might slowly change their interest in genre or in artist. The signal that we have to pick up here is the green signal. That's the true signal of users' preferences. If you don't correct for this in ways that we suggest, then you'll begin to make mistakes. And so all of the previous methods are represented by this green curve. They don't correct for this, and you'll see that they're off when there are sudden changes, but they're also off when there are more gradual changes.
Maarten, could you just make sure you point toward, keep talking toward the microphone rather than turning to the screen, otherwise you'll lose sight.
I'll hold on to the table. Right, so I think this is a nice example of safety, addressing safety concerns, right? Not only in terms of working with off-policy data, but also of trying to correct for any biases that might arise if you don't take real human preferences and their changes into account. Next example. Again, safety. And this is not a cold start problem, but more of a warm start problem. So we've developed a ranker that works well already, and what we need to do is learn to re-rank it to make it even better. Now, previous methods that tried to do this typically started from scratch, and in a sense, they did not take on board all of the experience that you already have with running systems. So what you need to do is take a running system. It does reasonably well, otherwise you would not be running it, and now make it better. So how do you do this? Well, that's ongoing work by Chang, who's also somewhere in the audience here. Oh, there you are. Good to see you. And so what's important here is you don't learn from scratch, but learn from the experience. That the experience could be encoded in different ways, but certainly it's encoded somehow in a reasonably well-performing production system, and then you gradually make it better. One more example, especially for deep learning-based ranking methods, we need tons and tons of data to make them perform well. If we don't have tons and tons of data, they actually don't do as well as they should. So here the safety concern is get the tons and tons of label data to learn from. Well, we don't have this. Well, not in a traditional supervised manner. There are tons and tons of other types of data, namely interaction logs. Can't we learn from those? Yes, we can, as of this year. And so what you see in the plot here, and I'm not allowed to look around, so this plot there, we're learning a neural method. We're training a neural method using, again, bandit feedback, so logged interactions. And of course, initially, we're a lot worse than with full information, with real labels, real supervised labels. But the more interactions we see, the more interactions we feed the neural network, the closer and closer it gets. And if you look behind me, then in that direction, there's lots and lots of interactions that it has seen, and actually begins to beat the full information setting. Here's another one. Before the break, you argued we should have a fairly broad vision of what an information retrieval system is, and I fully agree with you. So it could be a search engine, a recommender, a conversational agent, and probably many other things we haven't thought of. Just any type of technology that connects humans to information. And so increasingly now this is conversational. This is a dialogue system. What's important here is that the interactions that we have with these dialogue systems, as they feed us bits of information, as they try to get better and better understanding of what it is that we're looking for, what our information need is, that they remain not just relevant, but also interesting. And many of the state-of-the-art methods are maybe not as relevant as they should be, and certainly not as interesting as they should be. That's because they're typically trained to respond with the most common response. And that is often, I don't know, or something not very informative. So can't we do this better? Yes, we can, developing better models. What's an example? Here on the right, you see an example of two turns. So we have a speaker saying, we did a story on this guy, he owns half of Arizona, and then the response is he a fraud? And then the first, speaker A should generate a response. There are baselines, there's a reference, the ground truth, and there's new methods. What you see in those baselines, for instance, there are state-of-the-art baselines, sec-to-sec, sequence-to-sequence model. Yeah, no, I don't know who he is. So, might be appropriate, not very interesting. Alternative here, no, maybe he's a good man. What's the point here? Be diverse. Don't return the most frequent response. Return a response that is able for participants in a dialogue to continue the dialogue. One more example. So how is this safety? This is safety because you want to have users engaged. You want to keep them on board. You want to keep interacting with them. And so that goes, even in a task-oriented setting, and often wanders off into a bit of chit-chat, and then you come out of it and make it more goal-oriented again. Next one. This is on online learning to rank. So online learning to rank was born about a decade ago or so, a bit longer ago. The predominant method there is proposed, and many of them have been, many extensions of it have been proposed since then, is dueling bandit gradient descent. Roughly what it does is what you see illustrated in the picture here. We have a user who submits a query. We have a system, and we have a slight variation on this system. both the system and the variation generate a ranked list in response to the user's query. These two ranked lists are interleaved, somehow combined. This combined list is shown to the user, and then the user interacts with this combined list. And depending on where interactions land, whether there's a click, whether there's a download, what have you, you give credit either to one ranking system or the other, or to none if there's no interaction. Right, and so this has been a very influential method. There's some problems with it. It's not very good at optimizing really complex models. It's not very good also at achieving what we know on theoretical grounds could be achieved. So there's a considerable gap between what we know could be achieved and what it actually achieves through this type of learning. Can't we do better? And again, you want to be as good as you can be. That's safety. And you want to do this as fast as you can. So Harry Oosterhuis, another student in our team who's not here and not in Leiden but in Melbourne, proposed this method, pairwise differentiable gradient descent. It's the first online learning to rank method that's not based on dueling banded gradient descent. And what it does, it builds on this intuition here that it's pairwise. So it looks at pairs of items, and it tries to decide whether they're in the right order or the wrong order. This pairwise learning can be made unbiased in a way that's differentiable, and it doesn't rely on online evaluation or on sampling of methods, of models. And so it has this principle underlying it. That if you infer a preference of one document over another document from some ranking, and if both of these documents are equally relevant, then the flipped preference should be equally likely inferable from the ranker. If that assumption holds, and there are different ways of making sure it holds, then we can have a pairwise learning to rank method that's unbiased and that learns a lot faster than dueling banded gradient descent, and that also gets much higher to this theoretical ceiling that I mentioned before, and that where DBGB, dueling banded gradient descent, just couldn't get close to. So let me illustrate this with some simulated results on one of the Microsoft Learning to Rank datasets. What you see here is different methods, dueling banded gradient descent, so the state of the art until recently. The new proposal in blue and red, pairwise differentiable gradient descent, with a linear underlying ranking model and a neural underlying ranking model. And the first time ever, you see us getting a lot closer to perfection, to the theoretical ceiling, and you see for the first time ever neural beating linear. That's good news if you needed that subtitle. That's really good news. Okay, that's all about safety. Right, so the different readings of safety. You don't want to hurt people. You by giving them results that are worse than they can be. You want to learn as fast as you can. You want to learn the best possible ranker, and you want to learn result lists that are not biased. Not biased for particular results. Not biased for particular aspects of a collection. Let's move on to this other aspect of retrieval as interaction, so this explicability. If indeed retrieval is about humans having a search conversation, if you like, with machines, then that machine should occasionally be able to say, here's how I function, or this is why I made this decision, or even this is how I came to this wrong decision. You know what this is by now? Yeah. Did everyone hear that?
No.
So who?
I think that's South Amsterdam.
Amsterdam Zuid, yes.
Yeah, Amsterdam Zuid, I should say.
Zuid, Zuid, Zuid.
Forgive my Dutch. Thank you for the lesson.
Forgive my Dutch, pardon my French, yes. Anyway, explicability. So don't forget, with these machines operating in the wild, trying out new things, and they have to try out new things, otherwise they don't learn. To some degree, we're the patient receiving a treatment, but we're also the doctor who dictate what the treatment should be. And so we're both in different roles, in different parts of our lives. We're the subject of these interventions, but also the object. And so this explicability question comes up really naturally, right? Just a question such as, how does it work at a global level, but also, how did you arrive at this decision? How did you make this mistake? How could this go wrong? And so, again, I want to give you a few examples, and then I'll stop and zoom in for a bit longer on one of the examples. So, this is based on work that Maarten did, who's also somewhere here, yeah? It's about explaining rankings in a news recommender system. This was a joint work with a news publishing platform. They send out recommendations, and they're a responsible news publishing platform, so they were really concerned about, can we tell our readers how we came to produce these recommendations. The method here is based on the following intuition. You find the importance of different ranking features based on the idea of perturbation. You make some changes, you see what happens. If you make changes to feature values and they don't really change the ranking, then probably that was not a really important feature for the production of this rank list. If you make some changes to the values of a particular feature and you see big shifts in the ranking, that probably is an important feature for this particular ranked result list. Right, so this is an important idea. Make changes, see whether they have a big impact on the end result. If yes, then this is something you should pay attention to, because that's a big contributor to the result list. Now, once you've identified those, you then need to map them into a human language, right? You can't. This recommender is based on a learning to rank method. You can't really explain the learning to rank method, but you can explain the important and deciding, most strongly deciding features by describing them in natural language. And these are very common things. You're seeing this partly because you like to read this author. This is sport and you often read sport, or this is from The Guardian and you often read The Guardian. Right, so those are the types of natural language translations of the ranking features that we would show and display to a user. Now, a couple of things played a role here, not just going from under the hood to these natural language descriptions, but also doing this faithfully. What we claim to be an explanation actually is an explanation. These really are the ranking features that matter most. but also this needs to be done in real time. And it turns out that if we do what we just described, we can't do it in real time. So then something else needed to be done. Learn a neural model that mimics this mapping from perturbations to feature values to those explanations. You can do that. You can develop such a neural network. You can make it highly accurate, and you can make it run in real time. So what happened here was, again, a news recommender. Let's explain why people see these results that they're seeing. Identify the most important features. It's a process that's too slow, but we can learn something that does almost exactly this, and it's sufficiently fast. And that's run. Great. Now, what does it do with users? Well, it shouldn't hurt them, and it should not hurt the publisher. So ideally, nothing much happens. Right? You offer explanations when people want them. You don't push them in their face. So there are different ways in which you could do this. For instance, a little question mark bubble next to the results. Tell me. And then initially it led to increased engagement, but after people got used to it, sort of engagement reverted, if I remember correctly, Maarten, to the levels that we saw before. So this is good news, right? This is just a news publisher becoming more responsible and making sure both playing its societal role, but also making sure it doesn't cost him or her any money. Here's another example by Nikos, who's also somewhere here, who actually led us here, yes. Thank you, Nikos. Now, so we talked for quite a bit before the break about collections. So if we do retrieval, where do we get results from? Now, one of the comments was these collections become increasingly heterogeneous. Could be documents, could be structured data, could be signals, could be what have you. And so increasingly in the search engines that you probably use on a day-to-day basis, it's already quite a rich mixture. It's heterogeneous, and it has at least document streams, possibly new streams, but also a knowledge graph. So semi-structured data, probably fairly well curated, and so results might come from documents, but they'll also come from the knowledge graph. Now, if you retrieve a simple fact from the knowledge graph, how useful is that? At least when we return a snippet from that represents a document, the snippet gives a bit of context. You can understand how that document could be relevant even from the snippet, if it's an okay snippet, right? Because you get a bit of context. With just retrieving a fact from a knowledge graph, there is not a whole lot of context. So the explanation angle that Nikos brought in here was make these individual facts potentially more useful, or at least make it easier for people to decide whether they're useful or not by giving context to these facts. So collect surrounding facts. Now, that sounds easier than it is because these knowledge graphs typically are huge. And at the end of the day, everything in a knowledge graph is connected to everything else. So you cannot just take a triple from the knowledge graph, because if you do this, then you actually pull the whole knowledge graph in. Right? Everything is connected to everything else. Okay, what do? Well, you limit yourself. Don't go too deep into the knowledge graph. Rank, possibly learn to rank, possibly relevant other facts from the knowledge graph, both based on on supervised learning to rank, so features that we thought up using, let's say, editorial insights, what makes effect important, what makes effect central. You can compute this with the familiar TF-IDF type properties, but you can also compute this with graph-based properties, and combine this with features that you learn, features features that a neural network will pick up. Okay. Yeah, so I'm doing some retrieval in my head now of where did I pick up this sound before. My first association is actually an old Indian temple somewhere in Amsterdam. What was I doing in that temple? Well, we can talk about that over drinks. Right, so the second example of addressing the explicability. Now here's an interesting one, or an even more interesting one, I should say. Sorry, Nikos. This is about fashion recommendation. What should we do as information retrieval people with fashion? Well, it's actually an interesting recommendation problem because you have to, in this case, learn not just some recommendation task, but you have to learn aesthetics. You have to learn visual beauty to some degree. And then you can do the visual matching that will make a user happy with a recommended item. And so this is joint work with Peng Jie, who couldn't be here today, unfortunately. And the great idea he had was, can we make the recommender answer the question at the top there? What were you thinking? When I gave you a piece of clothing that I want a new recommendation for, and the task here is you offer it a top as an example, and it should suggest you some a bottom piece of clothing, or the other way around. It should somehow get an idea, get an image of what it should be, that it has to recommend. And so that's what he trained a neural network to do. So what does that mean? He trained a neural network that could imagine pieces of clothing. And then found a real one that was close to its imagination. So that's what you see over here. You see pairs of rows, columns, pairs of columns, real and imagined, generated by the network. And then it used the generated items to, in a sense, develop a sense of aesthetics. And of course, these are hand-picked, these examples. These are all reasonably okay. I can assure you there are also some examples that are not okay at all, but they're not for public demonstrations. Again, this is about explicability, but in a different way, and also with a different modality. And it's not just enriching a recommender with this additional functionality, but it actually helps the recommender to perform better. Another example, this isn't work with Boris, who's also not here today, but in Moscow. This work was inspired by a demo that went wrong, a demo with a dialogue system and it produced utterances that were hopelessly off. And this was an important demo with important people observing the demo. And so that led to the engineering question, what the hell happened here? Why did we get this response? And now, of course, if you know anything about machine learning, what you could do is just leave one out on all of the. I think there's a local.
Sorry for putting you off.
There's a local cold weather patch there, I think. Yes.
And a very bad old neck.
I hope this helps. You could leave one out on all of your training instances and see whether you no longer make that weird decision. If you have tens of thousands of training instances, that's not a good idea. So we wanted something more efficient, more effective, basically trying to answer this question in red here. What happens to the outcomes if we change the weights of some of our training samples? Make them more important, less important, totally absent, what happens? And so what you would want in that case is that if you have a method that identifies training instances that are in a sense responsible to most strongly responsible to give an outcome, then if you adjust the weight of those instances, you should have a change on the outcome, but anywhere else, ideally nothing happens. Outcomes are what they were before. That's what the method can do. So it gives explanations not so much to end users, but to engineers. Now, here's, to me, one of the most puzzling bits of recent work that we've done in this space of explicability. That's together with Anna, who's also here. And it's about trying to automatically explain errors in a prediction. And this happened to be a retail forecasting prediction, but it could have been any other scenario where you have people who get the outcome of a predictor, and sometimes the predictor is off, way off, and you need to explain why it was off. The people who work with the outcomes of these predictors, they are not machine learning people, they are not computer scientists, they're analysts, and they may need to make decisions on, in this case, purchase volumes or staffing volumes or what have you. And so the question we're facing is, we know we can give them better models that do better predictions, but still there will be mistakes in the predictions. How can we explain those mistakes? Now, it turns out that in the literature, this problem of algorithmic decisions, whether in a classifier, a predictor, a ranking scenario recommender, doesn't matter, but if users are confronted with errors of those systems, they're less likely to use the model and even revert to poorer decision making by giving up on models altogether. And so that's not a situation we want to be in. So our question was, can we help and improve this? Somehow generate explanations and build trust. And so here's the method. In plain English, the method, so generate contrastive explanations by identifying unusual properties of a particular observation. I'll give you an example on the next slide. And then assume that large errors that you observe are due to unusual feature values in the test set, and you've not seen it in the training set. And so given an observation that results in a large error, the idea is generate a set of bounds for each feature that would result in a reasonable error as opposed to a large one. And so to add on top of this and hopefully increase trust even more, include the trend of a feature value as part of the explanation. And so here, just to make it a bit more concrete, remember this is in a retail setting. Here are some of the features that play a role in that setting in making predictions. So the first has to do with total contract hours of an employee, and the trend there is as the input increases, then sale increase. So if someone spends more hours, if people spend more hours in the shop, then the shop normally would also generate more sales. And the value that we obtained there was an outlier. The reasonable range was a lot lower. Similarly for other features, advertising costs, again, input changes, increases, then the sales should increase. So you advertise more, you get more income. The value there, the advertising costs, and then you have the reasonable range. Now, evaluating these explanations is hard, is really hard. We talked before the break about evaluation of relevance. This is harder. And here's an example to illustrate this. So one of the things that we did in the evaluation was a user study with subjective questions, but also user study with other types of questions. And these are questions about self-perceived understanding of a model. And so you see them on the right-hand side. I understand why the model makes large errors in predictions, or I would support using this model as a forecasting tool, or I trust this model, and in my opinion, this model produces mostly reasonable outputs. And then we did a before and after measurement. Before we gave an explanation automatically generated, and after we gave them an explanation. And here's the surprise. Let's go through each of these questions again. I understand why the model makes large errors in predictions. Okay, after the automatic generation, you see more people agreeing to this. Yeah, right, we gave them an explanation after all. Second question, I would support using this model as a forecasting tool. After the explanation, yeah, more people saying yes. Good, success. Next one, I trust this model. After the explanation, less people trust it. What's going on here? Last one. After the explanation, fewer people said, in my opinion, the model produces mostly reasonable outputs. You understand more about the model, and you think it's less reasonable. So this is a big challenge, not just generating these explanations, but also understanding when you've got it right, when it's a useful explanation, when it's not, how it depends on a task, on background knowledge, on I don't know which factors, probably all of the factors that we're used to from good old-fashioned information retrieval or recommender systems, and a few more. So there is an interesting conflict here. Users can support a model's deployment without trusting it. Right. So if you're looking for problems to work on, start here. So let me try and wrap up. We're back in Amsterdam-Zuid. So we've looked at this concept, search more as a conversation, recommendation as a conversation, IR in general as an interactive system, systems that would then need to observe the world around them, reason about it, take actions. there's some obvious dimensions that then come up when you look at a world like this, having to do with safety, having to do with explicability. And there's plenty of questions here to work on. How do we make systems better understand people? How can we do more and better and more realistic online experimentation without owning a large-scale search engine? How can we develop mixed initiative systems where sometimes a person takes an action and then the system takes an action, and the system asks questions to be able to take better actions? How do we make good teams of systems and people? Hybrid teams that together make better decisions than apart? If we don't have live systems to experiment with, how do we create good simulations that are a good indication of reality? I've focused only on the machine side of the story, but of course there's a whole human side of the story that we should work on as well. Some of the colleagues in Leiden are working on search as learning. I think that's and someone in the audience too. I think that's an important direction as well in this context. And finally, remember, this all started with a picture where we have offline development and then online development. And then after that, we were mostly, in the talk today, we were mostly online. Our text material, our textbooks, stop at that first step. We badly need an update. We need lots of updates. So next time you have an opportunity to write a tutorial, do it in this space. Because we need this. So let me stop by thanking organizations who made the work that I presented here possible, and all of the students and colleagues who worked with me on this. Thank you.
Thank you, Maarten, for a very interesting and I think challenging presentation. And the floor is now open for discussion. Just remind you to hold the microphone close to your mouth so that the sound can get not only around this room but also all the way to Leiden. Thank you.
You were talking about safety and that, as it were, protecting the users from the algorithms. What about the other way around? Are you working on how you protect the algorithms for users? How do you stop algorithms picking up biases from users in terms of kind of gender, race, and things like that?
Yeah, fantastic question. Thank you. And yes, that's very much also part of the work. Trying to automatically de-bias signals that we get from users, trying to also make sure that if we produce result lists that we're sufficiently diverse and we show different aspects, different tastes, different likes. We know we have to be careful there, but we do think it's important to do this. Yeah. There was another question in the middle here.
I would like to relate to your abstract lecture with a very practical example that I have in the workplace. I work in the library of a city law firm, and 2 hours of our job in the morning is about sifting through hundreds of articles, case law, and other pieces of legislation. Putting together a newsletter which can be read by the fee earners and lawyers in the firm and are not overwhelming. I'm new to the library, and I try to pick the brain of my colleague who's been working there for 17 years, who's receiving feedback information from lawyers and partners in the firm, and I'm trying to mimic what she does, but I cannot explain what she does. And I don't think that she is able to explain. She just gives me a signal, yes or no, and sometimes when she can explain, that's a moment of miracle. And I think it's only the 17 years of experience and the feedback of hundreds and hundreds of lawyers working in the firm, which creates the result on a day-by-day basis. I wonder whether a formal system would be able to achieve the same result as the 17 years of my colleague.
Well, you know, give a system enough data and you'll be surprised as to what it can do. Give us enough compute power and you'll be surprised to see how we can train our networks to do amazing things and outperform humans. In this particular case, this is a really complex task, which has many, many dimensions. Could we approximate her? Probably not. Could we do some things better than her? Probably, yeah. I would imagine that at some point she would be working with a system that does something reasonably well and probably does it slightly differently than she does, and that she would be inspired by what that system would do, and the system would be inspired by her.
On an abstract level, is that fair to say that we do not have to always understand what happens? As long as we have the good result.
Yeah, well, we do that actually every day. Most of my interactions with humans are full of puzzles. Right, and actually my somewhat incorrect remark here would be, when someone talks to you about black box models, don't trust them. We work with devices that are way more complex than anything we've built computationally, and we've done that for millennia. And so I do think that it's actually potentially blocking for innovation if we insist on full explainability. We can't. We just saw from some of our own experiments, even if we can explain this, then the effect it has on human behavior and decision making is surprising. So just saying this has to be explainable, that's not a solution at all. I do think transparency matters. So people should get the idea that they are in control, that they can ask the question, what do you mean? Right, I could do that, you could do that to me too. What do you mean? And then you expect a reasonable answer from me. And we should be able to do that with systems as well, so that people can actually work with these systems and hopefully make better decisions.
So with respect to bias, I'm in two minds. Let me give you two examples. If I was after some music recommendation for myself, I quite would like the system to be biased towards my taste. I would prefer that. But if it was about deciding on a mortgage application, I would be horrified to learn that, say, certain gender or race would influence that decision. And I would be interested to hear your comments about bias in those two situations.
So by definition, any of these systems has to have some bias, otherwise they would be totally useless. Even the mortgage machine would have to have a bias. It needs to come up with a first answer or a first result. It cannot just say, well, here are 5,000 options for you. Have fun. No. So some sort of bias is essential when you have large amounts of information. Now, what type of bias is acceptable and what is not? Certainly, based on some of the criteria that you just mentioned is unacceptable. Bias that in a mortgage setting, or probably in every setting, bias that caters for my musical taste or your literature taste. Sure, we also know that but even there we know if we become too biased and don't occasionally inject something out of the ordinary for you, you lose interest. Some people are a bit more resistant to occasionally hearing something new in their Spotify feed, or getting, where does this book come from in Amazon? But we do that, and we know that if we do that, people actually engage with these cultural artifacts more. So yes, a lot of bias, but also explicitly ignore it for the cases of cultural artifacts. Now, at the other end, we also know that if you think you want to do the right thing, for instance, you're a news recommender, and your user is maybe extreme anti-vaccination, and so this user searches for stuff related to vaccination, and you think it would be intellectually helpful or socially good to also show that person other results. It has actually, in many cases, has the opposite effect. They become more extreme. So you have to be careful in taking sort of the moral judge position as a system.
So as a final question to that, how do you control for bias in your data sets and in your systems?
Well, okay, then phrase like that, I can't answer the question. My reply question would be, what type of bias? There are many types of bias. Even in these interaction logs, we have bias because search engine results have position bias, there's presentation bias, there's context bias. In many cases, we can correct for this. Sometimes by some interventions, we can do randomization. In other cases, we make certain assumptions, and we correct for this by allowing for more uncertainty. For instance, when we do evaluation based on these logs or learning from those logs.
Okay, thank you.
Maarten.
Hey.
Is this on?
Yep,
Doug?
it is.
Yeah, good. Okay. Maarten, the really gripping talk covering things I've struggled with, and in many cases progress on them, but things I've struggled with for how long? 40 years now, something like that. So it's absolutely wonderful from that point of view. And if I may digress to a comment to the second questioner, about 15 or 20 years ago, Sue Dumais and I, Sue Dumais, a former winner of this prize, were in a place called Lorne in
Australia?
Western Victoria, southwest Victoria. I'd say not too far from Melbourne, but only by Australian standards. As I recall, you'd be out of the Netherlands no matter where you started from if you travel that far from Melbourne. But anyway, this place, we were at a workshop, and the workshop, we invented an idea called artificial intuition, right? And this was based on a comment I made that in order to get the sort of search results we wanted, initially I said telepathy, we'd need telepathy, which is clearly way beyond artificial intelligence. And she said, we don't need telepathy, we need intuition. And there was then a conclusion that much of the things we wanted could be achieved if only we had enough data in order to develop our intuition. That you talk about genetics, you talk about the learning of an individual organism, you start to realize the scale of learning, and that's what we're applying to problems such as the one you described. And now in some cases we can do these things. Certainly modern search systems can do it because they exhibit artificial intuition because of the volume of data. So it really has happened. In your librarian's case, not easy, but doable. But what I really wanted to ask was, there were two topics that when you began, I thought you might cover. One's I've struggled with, many in the field have struggled with. One you've covered indirectly with the when you started talking about the problems of providing appropriate recommendations to searchers who may have their own views of the good data, what's a good result, in effect. You know, this is a well-known problem, and I think you've indicated how difficult it is and where you might go with that to some extent. But the other one is, how do we recognize really true results? You went into knowledge graphs. Knowledge graphs can, of course, have erroneous information in them. It's not just finding factoids that look like they're the right sort of factoid. It's the factoid that is, in fact, true in some sense. Do you think we've made any progress with that? And do you think there are prospects for making progress in the future, the near future? Thank you.
Yes and yes.
Good.
This is an important problem, and this whole area of knowledge graph maintenance, for instance, because these facts may be true during some part of their life, and then they become false. They might become, think of CEO of a company, then is no longer a CEO, etc. And so at some level we've become better at this, namely being better able to, for instance, identify the temporal extent of relations. That's to a large degree due to more data and better machine learning. Have we made any progress on the underlying philosophical question? What is a true document? I'm not sure. Have we begun to understand consensus models better? I think so. Right? Have we begun to be able to distinguish maybe different positions around an issue, and then one of them may be true, but not almost by necessity, not all of them? I think so, yes. So diversity is an issue that many people have looked at, recognizing diversity in positions, in angles, also in sources, and in the truth degree of those sources. Yeah, we've made progress there.
Thank you.
Hi, I would like to. I'm working in an area. I've got involved with a Google Digital News Initiative project. So what we're looking to do is build a tool for journalists to verify information. And we're working with journalists in our journalism school. And what the journalists are saying to us, if the journalists do not trust the system, they'll walk away. Simply because it's not explained, or there's something there, or they lose control.
Yep.
Either way, they're out.
Yep.
How do we keep our users? How do we keep those types of users from walking away from our systems, from our search systems?
So we've worked in comparable settings, not with journalists, but with digital humanities scholars. To some degree, their work is like the journalists' work. We kept them on board by giving them control, generating explanations. Also, contrastive explanations were helpful. What if the query had been different? What would have happened? What would have been the influence of on the result list? We've also provided them with. They weren't tech people, so we couldn't really tell them. Well, here's one learning to rank method, and here's another. What we could do is provide them with interfaces so that they could quickly assess for instance, the influence of different query formulations. and thereby somehow get the feeling of being in control, right? If this is how I change my queries, and that's then the impact on the result list, well, at least that gives us a sense of control. And so that's what we've done, different search panels, result panels next to each other, different filters, so that it's not so much control of the underlying technology, but control on the outcomes, and allowing that good interfaces that allow them to do that very efficiently. That was the best that we could come up with then.
Okay, well, I think we've had a very stimulating afternoon. Sorry, I touched something. Dear me. Just one comment. I was particularly struck by what you said about transparency, picking up really Andy's point, and systems explaining how they reached their decisions. And I was thinking I would just love in Google, if I do a Google search and something comes up at the top of the list, I'd love it to have a little question bubble next to it, and I can click on that, and it says, we've put this here because the retrieval system evaluation that developed by Maarten, Rijke and colleagues says it's relevant to you. Or much more likely, we put it there because somebody paid us a lot of money to put it there. Right. Okay, well, let me conclude the meeting and thank Maarten once again for his interesting presentation. And just before you go, can I ask you to keep an eye on the UK EIG website? Because I think, am I right, Gary, today's proceedings will be on there in due course?
Yeah, we'll make sure everything is available. We just have to discuss it with the speakers if they're happy with the presentations.
Okay.
There's also a recording of the event for colleagues who couldn't make it today.
Right, okay. The recording available if you colleagues were not available to be here today. And also on there, of course, in due course, will be details of the 2019 Tony Kent Strix Memorial Lecture. So keep your eye open for those. Thank you.